In this lesson, we take a look at the options in the global DMC rollout. If you have used V-Ray in previous versions, you might remember how much time we used to spend here to try and optimize our image sampling. But with V-Ray 3 and especially the third service pack of this release, which changed the way V-Ray used to sample the scene and improve upon it significantly, the parameters in the global DMC rollout are barely touched in a production workflow. DMC stands for Deterministic Monte Carlo, which is a method for calculating blurry values like area shadows, glossy reflections, depth of field, and so on. As we discuss sampling and how V-Ray does it in quite a lot of details, we can go ahead and start explaining the parameters in this rollout. First, we have lock noise pattern. When enabled, the sampling pattern will be the same from frame to frame in an animation. And sometimes this is really not good. By that I mean if you render your animation and don't have very high quality sampling settings and have this option on, you can clearly see the animation is floating underneath a stationary noise, which is really obvious and bad. But sometimes you might want this option on. In general, you don't have to touch this option and it can be disabled. Next, we have use local subdivs, which we discussed in our previous lessons. When disabled, V-Ray automatically determines the subdivs for lights, materials, and other shading samples based on the mean shading rate value. But when enabled, the actual subdiv values from the scene will be used. When use local subdivs is enabled, we get another parameter called subdivs multiplier. And this is going to multiply all the subdivs in the scene by the number you specify here. This multiplier affects all the subdivs values in the scene except for the image sampler subdivs, light cache subdivs, caustic subdivs, and photon map subdivs. Now, if you for whatever reason don't like the new sampling workflow and like to manually tweak all the subdivs in the scene, you can simply turn on use local subdivs, set mean shading rate to 1, and disable divide shading subdivs. After that, you simply go ahead and check out your lighting render elements, and if there was any noise, you can simply increase the light subdivs. If the reflections were noisy in the reflection render elements or in the RGB paths, you can decrease the material subdivs until you get your desired quality. Increase the material subdivs until you get your desired quality, which normally leads to very long render times, and I don't recommend doing so. On the right side of the rollout, we have mean samples, adaptive amount, and a secondary noise threshold. Next, we have mean sample. If you remember in the previous discussions, I mentioned that for image sampling, first we send a few initial samples, and if the values of those samples were close enough, we wouldn't need more samples to send. And if the contrast was big enough, we would send more samples. And mean samples determines the absolute minimum of samples that must be used before stop sending those samples. Honestly, in most cases, this option doesn't affect your render that much and you don't need to alter it at all. Let me show you a few renders with different mean samples value. First, let's go ahead and make sure mean shading rate is set to 6, divide shading subdivs is enabled, and use local subdivs is disabled. As you can see, I have 4 renders with mean sample set to 2, 16, 128, and 256. As it's obvious, the render time is pretty much the same. There isn't any noticeable difference between the quality of the renders, and that's mostly is one of the welcome side effects of the new improved sampling algorithm. So as you can see, you really don't need to alter this value in most cases. Let's make sure mean sample is set to its default of 16. Next, we have adaptive amount, which controls 2 things. First, how much the number of samples depends on the importance of a blurry value. For example, a bright glossy reflection is more important and needs more sample in comparison to a dim glossy reflection. Also, it affects the mean number of samples to be used. 1 basically means full adaptivity and 0 means no adaptivity. In theory, 1 means V-Ray can have no mean samples or mandatory samples, and 0 means all the defined samples need to be used. Let's take a look at a few renders. In the first render, the adaptive amount was set to 1. The next one is 0.85, which is the default number. Then we have 0.7, 0.5, 0.1, and 0. As we go from 1 to 0, you can see the noise becomes cleaner and the render time increases. So if I compare the version with adaptivity set to 1 and the one with 0, you can see the 0 version is cleaner because VRA is forced to use more samples and be less adaptive. Normally the default value is good enough and you don't need to adjust it that much. Now down here we have a secondary noise threshold, which, if I quote Chaos Group website, controls VRA's judgment of when a shading value is good enough to be used. End of quote. Honestly, this noise threshold is not going to do much in this new improved sampling workflow, so you can leave it alone. That's about global DMC controls. In the next lesson, we are going to take a look at the image filter rollout. See you there.